Hello everyone. Today we are going to discuss about the mutually exclusive events and the independent events, which is the topic of the probability. So the first thing that we are going to do is the understanding the proper definition of mutually exclusive events. The mutually exclusive events is the situation in which the two events cannot occur at the same time. The non-occurrence of the one event is the occurrence of another event. The sets in the mutually exclusive events will not overlap. It is also called the disjoint events, and the probability of getting two events happening at the same time is zero.
So the formula of mutually exclusive event is so now I am going to take the real life example of mutually exclusive event. So tossing a coin is the real life example of mutually exclusive event. If we toss a coin, there are two outcomes, heads or tail. So the result can either go heads or tail. So the probability of getting heads or tail is zero at the same time.
So now we can understand mutually exclusive with the example. So what is the probability of a die showing number 3 or number 5? So the P3 is denoting the probability of getting number 5 and P5 is denoting the probability of getting number 5. And so whenever we throw a dice to getting a single number, the probability is always 1 by 6. So according to the formula, so here we can see that we are adding the 1 by 6 plus 1 by 6. So we are getting 2 by 6. So whenever the probability of dice showing number 3 or number 5 is 1 by 3. So whenever we throw a dice, the probability of getting number 3 or number 5 is 1 by 3. Going to discuss about the independent events. When the occurrence of one event does not control the happening of another event, then it is termed as the independent event. There is no influence of occurrence with the another events. The sets will also be overlap in the case of independent events.
Formula of independent images. I'm going to tell the real life example of independent event. So if we flip the coin, so we get the outcome as heads, and again if we flip the coin, but this time we get the outcome as tail. So in both the occurrence, the events are independent to each other.
We are going to understand it by independent exclusive events. For example, so x and y are the two independent events. X is 0.3 and y is 0.7. So we are going to find the probability of x and y, x to y, and y not x. So here we can see that x and y, we are going to multiply it, which is the 0.21, and here we are going to find x over y. So we are going to add both of these, and which we are going to subtract from the multiplication of these. So the answer result is 0.79, and now we are going to find y not x. So here we can here we are subtracting the probability of y from the multiplication of x and y. So we can see that 0.7 subtracted from 0.21, which is 0.49.